In this video, we're going to look at how to solve absolute value inequalities. When doing this, we're going to still apply that definition we covered the absolute value equations, that the absolute value of an expression represents the distance of that expression from zero on the number line. We're also going to apply compound inequalities, which were covered back in Algebra 1, and you should be able to catch on to them very quickly in Algebra 2 to assist us. Now, there are two types of absolute values that we're going to be working with. We're going to be dealing with less than or equal to absolute value inequalities, and we're going to be dealing with greater than or equal to absolute value inequalities. Let's first examine less than or equal to. Now, if you have the absolute value being less than, that means your distance is within or between those two numerical values. That's going to create an and compound inequality. Now, that's important. We always remember that less than are going to create and compound inequalities. So one way is that you mispronounce the expression. Less than tells you to create an and compound inequality with those. So if we just look at what it means for a compound inequality, if I have the absolute value of x is less than or equal to a, that means my expression x is within, because it's less than a, it is within a units of 0 on the number line. So here's 0 on the number line. X is located within a units. So it's located within, so between those two values. I go a units to the right, I go a units to the left. Somewhere in between there is my x. And so that's why we can write our absolute value inequality written like this. Negative a is less than or equal to x, which is less than or equal to a. So this is an and compound inequality. Your x is between the positive and negative of the expression. When dealing with a greater than or equal to, that means your distance is outside or beyond the numerical values. And so you're going to have an or compound inequality. So just like before, we have to realize when we're dealing with greater than, we're going to mispronounce that as well. We have greater than, and that tells us we create an or compound inequality. So same idea. The absolute value of x is greater than or equal to a. What does that mean? It means that expression is outside a units from 0. It is greater than a units, so it's going to go beyond a units. So my solution space is pointing to the right, extending beyond a, so x is greater than or equal to a. But if I go towards the left, it has to be beyond this distance. It's going to be pointing outside as well. And so this is read as x is less than or equal to negative a. And so those are the two inequalities we're going to be working with. So when you're dealing with solving absolute value inequalities, what you want to ask yourself is, how do we solve it? We solve it very similar to how we solve compound inequalities. We're going to get them to itself as you isolate the absolute value. Isolate just like we learned before. Remove any constants on the outside, remove any coefficients from it, then convert it to a compound inequality. So as soon as you isolate it, you have to determine, am I dealing with an and compound inequality, or am I dealing with an or compound inequality? That's the first question you should ask yourself after you isolate the absolute value. Then solve using the same approaches as we do for compound inequalities. And again, just like we did for equations, we have to check our solution. And we're going to graph the solution space as well. So main key you're going to have to figure out is working with and working with or compound inequalities. That's going to be the process we're going to have to focus on a lot in this part of the video series.